I am Dr. Shalini Sharma, and today we will be covering the topic of correlation in this video session. Now, correlation is very important in research. In number of research, the technique of correlation is used to do the statistical analysis. So, it is very important to gain the knowledge of this subject. So, let us start. Today in this video session, we will be covering meaning of correlation, what is linear and non-linear correlation, correlation coefficient, the Pearson and the Spearman correlation coefficient and their interpretations, then uses and limitations of the correlation coefficient and the various other types of correlation. Let us begin. Here I have taken number of examples of two variables which seem to be related. Just take the first one, the temperature and the ice cream sale. Do you think they are related? Do you think temperature has any relation with ice cream sale? With the rise of temperature, is there a rise of ice cream sale? Similarly, do you think is there any link between lifestyle and health? Is following a particular good lifestyle, does it have any relation to health improvement? Or unemployment and inflammation? Similarly, happiness and longevity, smoking and lung cancer. This is a very common example which is being given, that smoking is related to lung cancer. Increase in smoking, does it lead to any kind of increase in the probability of a lung cancer, or eating habits and weight? Similarly, there can be many other examples where two variables are related. Now, when we are talking of correlation, we generally avoid using the word independent variable and dependent variable, which you generally know the terms. I assume that in experimental kind of researches where we have much controls, we use independent variable IV or DV. But during this session, although it seems that yes, one variable can take the role of IV and the other can take the role of DV, yet we will avoid using these terms. Now, what is correlation? Correlation is a statistical method to study the relationship between two or more variables. It is a measure of association, this word is important here, between two or more variables, and this relationship or association is determined by two factors, the direction and magnitude. Direction can be either negative or positive, and magnitude can range from low to high. Now, the correlation values can range from +1 to -1. It means that correlation cannot exceed +1 and cannot be lower than -1. Sign here denotes a direction and the number here denotes a strength. So, +1 is a very high strength. A correlation of +1 or -1 is called perfect correlation. What is a perfect correlation? Or it means that change in value of one variable is exactly proportional to the change in the value of the other. You can take any two variables and x or y, and then you can say the change in value of the x variable, like a temperature, is exactly proportional to the change in value of the y, like the ice cream sale. Coming to the next topic, which is linear and non-linear correlation. Now, linear correlation again indicates that an increase in one variable leads to a consequent increase in another variable, or an increase in one variable leads to a decrease in other variable. So, it is just a a positive, a negative, or an inverse relationship, you can say. In that case, that is a linear correlation. So, there is a constant change in the value of one variable, okay, and with respect to the change in the other variable. Now, in a linear correlation, if you plot a graph, which we will just see, the line comes up to be a straight line. You can take n number of examples here. One is like a very common one, the relationship between hard work and exam results. We assume, we just say that yes, if you put more hard work, it will lead to a better exam results. Okay. Similarly, lifestyle and health. So, if you have a good lifestyle, you will have a better health. And an example of a negative or an inverse relationship is production and vegetable price. So, if the production increases, the vegetable price is going to go down. So, this is an example of a inverse relation. Now, there is other thing which is called non-linear or a curvilinear correlation. There are variables which are related not in a linear manner, but maybe in a curvilinear manner also. So, What is a curvilinear? When the ratio of change between two variables is not constant, it changes over time. So when you again plot the graph for the two variables which are not linearly related, then it forms a shape of a U curve. Okay, it can be inverted U or it can be a normal U. Example, which is a very common example which we take of a curvilinear relationship, is stress and performance. A good number of researches have been done on this. So when you see that stress is important for our life, okay, we cannot perform if there is no stress in our life. So basic amount of stress is required. So when stress increases to a particular limit, our performance in whichever sphere we can say also increases. But if stress keeps on increasing, then it might hinder our performance. So at some time when the stress is increasing, our performance becomes stable, it is no more increasing. And if the stress is further increasing beyond a particular point, our performance might decrease instead of increasing. So this is a U curve. So it is increasing till a point, then it becomes stable, and then it goes down. Similarly, you can take example of money and job satisfaction, in the sense that money motivates. We have heard of many, we have seen many researches, but then money motivates till a particular level. So money might give you job satisfaction, but beyond a particular point there are other factors which cause job satisfaction and not money. So money might keep increasing, but your job satisfaction might become stable or might reduce also. So these are the examples. Now coming to the positive, if I have already given example, but just more to give you more clarity on these. Positive correlation ka example, job satisfaction and work productivity. So if one increases, other also increases. Okay. So in that sense, if you are satisfied on the job, there are higher chances that you will be more productive at your job. Negative correlation is the inverse. So when one variable is increasing, the other is decreasing. So if you are satisfied, there are less chances that you leave the job. So employee turnover will be low. So job satisfaction will be high, but employee turnover will be low. There are cases when the two variables might not be related. There are n number of cases where the two variables are not related to each other. I have just given one example, you can think of many others. So eating particular food items would not affect your grades as such. So eating chocolates, it seems that does not have any link with the school grades. We can't say that people who eat more chocolates they perform better, or who eat less chocolates they don't. So something of that sort. Now if you plot the same things which I have just said, the positive, the negative and the zero correlation in the form of scatter plots. Scatter plots are the visual display of your correlation. If you plot your variables in the x and the y axis and then plot the scores, which we'll just see now. So in that case, the visual display, the graph which comes, is called the scatter plot. So you can see for a perfect positive correlation, that is +1, the first graph would be there, a linear straight line going in the upward direction. In the extreme right is the perfect negative correlation, which you can see here. This is a perfect negative correlation, where when the y axis, the scores, you can see the x axis, it is increasing, the scores are continuously increasing, but the y axis, the scores are decreasing. So you can take any variable. Okay. So in that case, if one variable is increasing, the other is decreasing. The last, the zero correlation, you can see there is no pattern in these dots. Okay, the dots are very scattered. We cannot exactly form any shape here. So it means that the two variables are not related. A linear relationship, you can see the example which I have taken is level of anxiety in exam score. It is similar to the stress and performance. So when your anxiety is increasing, okay, so it is low, when your anxiety is low, your exam score, it is also increasing steadily. When anxiety is increasing, your exam score is steadily increasing. So till this point of medium, you can say both anxiety is also increasing and your exam score is increasing. So, okay, so in a way it is healthy till a limit. But beyond that, if your anxiety keeps on increasing, then it might be possible that you are not able to perform well on your exam. So that's a curvilinear relationship. Now coming to the scatter plot, we will learn here how to make a scatter plot manually. Although when you use any software or Excel, then then scatter plots are automatically generated there, but here you will learn about how to manually make a scatter plot. So you have two axes. Whenever you have a graph, you have two axes, the x axis, the horizontal axis, the y axis is the vertical axis. Now you generally put one, although we can't say IV and DV, but when we are using later regression also, or when we see there is one one way kind of relationship, then you can plot the one variable which is seem to have the effect on the other, although again we can't use the word effect, on the x axis and the other variable on the y axis. For example, suppose I take the temperature and the ice cream sale. So we know that temperature still can have an effect on ice cream sale, but we can't say that ice cream sale would affect the temperature. So if you keep buying more ice cream, does not mean the temperature would keep on increasing. Okay, so for certain variable, this relationship so many times is, you can see the direction. But still, without any kind of experimental research, we cannot be sure whether which is causing which. So in correlation, both the variables can affect each other. So x can also have a relationship or affect y, and y can also affect x. In both the direction it happens. That is why we are not very sure which is affecting which. And in correlation, we are not worrying about that, the effect, we are just see whether they two are related. So this doesn't matter to us which is causing which. Now you see the range of values, you have to decide on the values which you will be putting and the difference between each value, that the researcher has to decide. Then what you will do, based on the values, you put a dot on the graph. Now we will take a hypothetical example here, and the study wants to study the there is a study which want to probe the relationship between sleep and mood. So is there any relationship between the number of hours you sleep and your mood, how you feel, how happy or not happy you feel. So sleep, they have taken a number of hours you sleep on one day, and mood is, they are taking a 5-point scale from 0 to 5, where 0 indicates not at all happy and 5 is extremely happy. Now the scores are such that if you sleep for 5 hours, then your score on mood is 2, and similarly if you sleep for 6 hours, your mood is 2, and likewise the other scores are there. Now what you do, you plot a graph like this, where you have plotted sleep on the x axis, okay, and you have plotted mood on the y axis, and then you have decided to keep the difference according to your data, what gap you want to do. Here is there is a 1-point gap, here is a 2-point gap. Now if you see the data, then sleep is 5 and mood is 2. So you take a point where 5 point where the sleep shows 5 hours and mood is 2 hours. So this is the point basically, you can see, and here you can put a mark or a circle, whichever. Similarly, let's see the other, which is 6 and 2. So 6 on sleep and again 2 on mood. So this is a 6 point, you can see 6 plotted and 2 again. So this is a point for that. Similarly, likewise you plot all the points for the two variables, and you have to see the shape. Now if you see the shape, then it is like a linear positive correlation till a point, and then you can say it is getting stable here. So we can understand from the graph, because we don't have more data, but if we have more data like 50 or 100 or like that, so we can see the graph, that what is the actual shape of the graph. Is it going down, is it stable, okay, so is it taking a linear shape, although it doesn't seem to be likely to be a linear shape. Why? Because it doesn't seem that if you sleep for 15 hours you will be very happy mood, no. So yeah, we think there will be a difference between if you sleep for 4 hours and 8 hours, but beyond a point we cannot say for surety that the number of increase in number of sleep would be leading to our happy mood. So that is a visual display which will clearly tell you the shape of the graph, how it will flow. Coming to the next topic, which is the correlation coefficient. Now the correlation which you want to assess is measured in terms of correlation coefficient. So there are two common, very popular coefficient of correlation. One is Pearson and the other is Spearman correlation. So Pearson correlation is given by Carl Pearson and it is denoted by R, small r. It's also called product moment correlation. And the Spearman rank correlation is named after Charles Spearman and it is denoted by the letter rho. Now it measures the strength and direction of association between two ranked variables. So we will see the difference, we will see the difference in assumptions of when do we use a Pearson correlation and when do we use a Spearman rank order correlation. So let us discuss first the assumptions of Pearson correlation coefficient. The first assumption to be used if you want to use the Pearson correlation and which you need to satisfy is that your distribution of variables should be a normally distributed graph. It should be a normal distribution, or you can say a NPC, normal probability curve, it should follow. So if your graph after you get your data and if it is following the NPC graph, then you can use the Pearson correlation coefficient. If it is skewed, then we say that it is not advisable to use the Pearson correlation coefficient. The second is the two variables should be measured at the interval or ratio scale, or they should be continuous. So I am not going into the details of the scales of measurement here, but as students of statistics, that's a basic thing we should know. There are 4 scales of measurement, the normal, the ordinal, the interval and the ratio. And for using the Pearson correlation coefficient, the data either should be in the interval scale or the ratio scale. The third is the relationship between the two variables is linear and not curvilinear. So we have just seen what is linear and curvilinear. So again, when you plot the data, when you have the data and you plot it, so you will come to know that if it is coming into the graph in a shape of curvilinear, then we cannot use Pearson correlation. Now Pearson correlation is very sensitive to outliers. What are outliers? They are the extreme scores, which deviate from the other scores. So when you see most of the time the scores whichever we are getting, they fall in particular ranges, and they are close to each other. But there can be very few extreme scores which do not get aligned with the other scores. Okay, so they are called outliers. Now outliers, I'll just show you the graph for visual display of outliers, will make you more clear. They change the whole calculation and then it affects the correlation coefficient. So if the outlier is way above the other scores, then it overestimate the correlation coefficient. If the outlier is below the other score, then it kinds to underestimate the correlation coefficient. Whichever way, you will not get a very right estimation of the correlation coefficient. So we will try to somehow get rid of this outliers. Now the last assumption here is that data has homoscedasticity or equal variances. So the two variables which you have, they should have equal variances, or in other way, simple terms you can say they have the same scatter between the groups. Let us first see what is outlier and then I will also show you the last assumption. Now outlier, as you can see, there are scores and you can see that they are falling close to each other, but there is one score which is way above the other, which is way different from the others. Now this is the outlier which we are talking about and which should not be there in your data if you want to use the Pearson coefficient correlation. Similarly, homoscedasticity, we can say the scores when they scatter is less, when they are less scattered, the variances are equal or equivalent, then we use then it is rightful to use the Pearson coefficient. If you see the right one, the heteroscedasticity, this is showing the scatter, scatter is different in the beginning and the later you can say. So this is not advisable here to use the Pearson coefficient correlation. Now what is Spearman correlation and when do we use it? Now Spearman correlation is a non-parametric statistic which is more appropriate when the data is not normally distributed. So, we have just discussed that for Pearson we require normal distribution assumption. So, if your data is not distributed, normally distributed, then what do you do? So, you can use this Spearman correlation. Or when your data is in ranks, or you can also convert your data into ranks. If you want to use the Spearman correlation, your data can also be converted into ranks. Okay, so when your data is in the ordinal scale or in the form of ranks, Spearman correlation can be used. When your data does not form the linear shape, then also you can use the Spearman correlation. Now, how do you interpret the correlation coefficient which you get? So, when you calculate your correlation coefficient either manually or using any software, then you get a particular figure which falls between +1 and -1. So, how do you make sense of it? So, it is said, this is general thinking, that if it falls between 0.5 to 0.7, it is a average or a moderate correlation. Okay, although when you do a real research, then even this is considered to be very good. Okay, then if your correlation is between 0.7 to 0.9, then it is highly positive correlation. Okay, or it is -0.7 to -0.9, it's a negative correlation. So, signs are very important here. And if your correlation is between 0.9 to 1, which is a very high or almost perfect correlation, which is not so many times is not seen in the real research. If you go down, then correlation which is less than 0.50 is considered to be, between 0.3 to 0.5 is considered to be low correlation, and less than 0.3 it is almost no or negligible correlation. Now, what is the function of correlation coefficient? Yes, one is that to find the correlation, if you want to do a research where you want to find the correlation, then but other than that, correlation coefficient is also used if you have done the psychometrics testing. Then when we want to obtain validity and reliability of tests, then also we are using correlation only, test, retest and everywhere. So, in that we are finding the correlation coefficient for verification of any theoretical claims which are made by any researcher. So, if any researcher has made any claims about the relationship of two variables, you can do it, cross check it by again using the method of correlation. For higher statistical analysis, then regression requires the knowledge of correlation, Markova factor analysis. So, this is all. So, the value which you get of correlation can be used for regression or prediction purpose also. Now, we also need to know what are the limitations of correlation. So, correlation, it does not tell the cause and effect relationship or causation that we should know, that through correlation we cannot find the cause and effect relationship. It is done through other kind of researches like the experimental researches. For discontinuous distribution, then which are not continuous, then the coefficient of correlation is not very good measure. Correlation is influenced by sample variation. So, if your sample is very homogeneous, then correlation is underestimated. You get a low value of correlation. So, if you want a correlation to be a right estimate, then your sample should be very diverse. So, your variability should be high in a sample. Similarly, sample variation, it also affects the range of observation. So, correlation also is affected by range. So, low, if the range is low, then the correlation is underestimated. Now, correlation assumes linear relationships. So, it is not fit for curvilinear. We have also discussed it earlier. So, what you can use other statistical analysis, like one is I have given, use correlation ratio or the eta. Now, correlation in itself does not tell you about prediction, but yes, correlation can help in later doing prediction and regression. Okay, so knowledge of correlation is required for doing the prediction. Now, what are the other methods of correlation? We have taken many of them, and we will take each of them now. When do we use these? in what conditions, but before that you also need to know what is a continuous, discrete and dichotomous variable. You cannot make sense of these kind of correlation coefficients if you don't know about these variables. Now a continuous variable is a variable, a numerical variable, which can take infinite number of values. Okay, all kind of values can be possible there. For example, weight. So you can be weighing 55 kgs, or you can be weighing 55 kgs plus 2.200 grams or even milligrams. So all kind of possibilities are there when you talk of continuous variables. Okay, similarly height, all kind of centimeters, millimeters, your height can be mentioned in any kind of form. Discrete variable. Now discrete is which can take any limited values. For example, if I say how many number of people are there in that room, so you cannot say 2.5. Okay, so they can take fixed figures only, limited and finite figures. So, or how many number of siblings you have, so you can say 1, 2, you can't say 1.5. So these are the discrete variable. Now what is important to us here is dichotomous variables. They are categorical variables which can take categories, and these categories are exclusive, mutually exclusive. You can fall in either of them, but you cannot fall in both. Okay, so either if you can see a natural dichotomy of a male or a female, then either you can be a male or you can be a female. Yes, there can be, now there is other category also, but in general when we take a talk of research, we say these are dichotomous variables because you can fall in either of, only one of them. Similarly, yes or no, you cannot say both whenever there is such questions. Okay, so you can say, are you hungry? So, or do you have a mobile? So either you can say yes or no, you can say both or anything. Head and tail, so any one can come, both cannot come. So within this also there is a natural dichotomy and there is an artificial dichotomy. A natural dichotomy which is naturally given to us, we have not made as researchers. So dead and alive, so either you can be dead or alive, you cannot fall in between anywhere. Okay, so in that case these are natural dichotomies. Male and female is a natural dichotomy, so humans have not made. So right hander, left hander, but artificial dichotomies are also there, which a researcher make for his or her convenience. So if you want to take a anxiety scale, okay, then there you are getting anxiety as a continuous variable, you can get n number of scores. But in researcher feels ki nahi, mereko it is very difficult to make sense of all of these numbers like 20, 30, 40, 80. What do? I make ranges. So I say that 0 to 10 is 0 to 20 is a low anxiety, and then 20 to 30 is a high moderate anxiety, and then above 40 or 30 that can be a high anxiety. So now what researcher is doing, they are forming categories. Okay, so if you are making two categories, it is a artificial dichotomy. Okay, so which is made by the researcher for the research purposes. Now coming to the correlation part, partial correlation, it measures the correlation between two continuous variables. We know continuous variables which can take any values, okay, and controlling for another continuous or a confounding variable. So we know when we take any research of two variables, there are many other variables which are also affecting our, the variable which we want to study. So in that case, suppose I want to study the relationship between age and memory, but I know that memory is not only related to age, memory might be related to education also. Okay, so I have to control the education part, I have to make it common, make it I have to take people who from the same educational category, something of that, so that I control that variable and it is not affecting or the memory, my variable of memory. Similarly, if you want to see the link between class attended and marks obtained, now class attended only does not have a relation with marks obtained. Now there can be so many other things, how many number of hours you are studying in a day, even that is also affecting your marks. So what do? I control the study hours and see I am only studying the relationship between class attended and marks obtained only. So that is a partial correlation, because you are keeping away the other variables which might be related to your variable. Now point biserial correlation. Point biserial correlation is a relationship between one truly dichotomous variable, which is a natural dichotomy, male or a female like, and one can be the other continuous variable. So when one of your variable is a continuous variable like a weight or a height or any other thing, or scores on some test, and the other variable is a dichotomy, but a natural dichotomy. In that case, you can use the point biserial correlation. For example, we can say relationship between sibling order and introversion extroversion. So that is a natural dichotomy. Now biserial correlation is when there is a correlation coefficient between two continuous variables, out of which one is measured dichotomously, that's an artificial dichotomy. So one is completely continuous and other is a variable which is continuous, but researcher has, because of the convenience of or whatever reason, has made it a artificial dichotomy. For example, as I said, if you want to take anxiety and if you want to instead of taking all anxiety scores, you have divided into low anxiety and high anxiety. So this is a dichotomy which you have made, and marks in exams is a continuous variable. So in such cases you can use biserial correlation. Tetrachoric correlation is correlation between two artificial dichotomous variables. So here you are taking both the variables have artificial dichotomy. So it's like a 2 into 2 contingency matrix. Example of personality. So you are dividing into extrovert and introvert, and job ka performance you can divide into success or failure on the job. Similarly, number of examinees who pass and fail on history and political science tests. So this is, or adjustment, social adjustment. So these are all dichotomies which are made by researchers. Okay. Now phi coefficient is a correlation coefficient between two natural dichotomous variables. So again it is a 2 into 2 contingency table, but the dichotomy here is a natural dichotomy, like a gender or a right-handedness, left-handedness, ownership of property, whether you own or non-own, nobody decides. It is either, if you have it you are a owner, if you don't then you are non-owner. Similarly, smoker or a non-smoker, or gender. All such relationships can be studied through phi coefficient. The last part here is the multiple correlation. So multiple correlation is when you want to study the influence of one, although we avoid IV and DV, but still in some cases we can use when there is a clear relationship which you can see. So studying the combined influence of two or more independent variables on a single dependent variable is called multiple correlation. For example, this you can see that if I want to study the relationship of IQ, number of study hours, health status, matlab how healthy I am, with the performance. So instead of taking one variable, I am taking three variables which can be related to performance. So in that case, I can see all these have some relationship, some effect, so I can still get a sense of this is IV and this is my DV. Okay, although we should avoid again in correlation these terms. Now there are other examples also which I have given, and you can take n number of examples: influence of illiteracy, unemployment, and size of family and crime rate. So that is multiple correlation. So in this video we have taken up correlation, the basics of correlation, the correlation coefficient, the Pearson and the Spearman correlation, the assumptions of both, and scatter plots, and the last part are the various other types of correlation. I hope you have gained understanding about these topics and learned the session and enjoyed the session. Thank you so much.